Hello students, the topic that we are discussing today is a very vital topic for IGCSE extended. It is probability. It is one of the topics which requires application much more than the formula analysis. So the topic is probability. Now, what does probability means? So literally the meaning of a word probability is whether an event will occur or it will not occur. So if an event is occurring, what is the chance of its occurring? So that's what is the meaning of the word probability. That means if any event is occurring, what is its chance to happen? What is its chance to occur? So the generic definition of probability of any event A is written as favorable outcomes, and that's divided by total number of outcomes. So that's the basic definition of probability. Now, as you can see that the favorable outcomes is selected of the total number of outcomes, right? Isn't it? So that's obvious that the favorable outcomes will be less than the total number of outcomes. So that's for what we say as that the probability of any event A should be greater than equal to 0, but less than equal to 1. So the probability of an impossible event will be 0, and the probability of a sure-shot event will be 1. We cannot have a probability which is greater than 1 or less than 0. That's because the favorable outcomes is a subset of total number of outcomes. And at most, the subset can be equal to the total set. We cannot have elements. We can select 5 elements out of 9. We cannot select 10 elements out of 9 because that's not possible. So that's for what we say that the probability of any event should lie between 0 and 1. So now we'll be placing few of the sums that deals with the basic concepts of probability, and we'll check out how does this work. So this is a type of question which is basically asked on the probability. So it says that a fair die is thrown once. Find the probability of obtaining a 6. So if I list the outcomes that comes from a fair die, so if a die is rolled, we can have the total number of outcomes. If I'm writing total, so it can be 1, 2, 3, 4, 5, and 6. So there are total 6 outcomes. Now, we are asking for a 6. So that's one of the cases out of total. So the probability of getting a 6 in a throw of a die has to be 1, which is our favorable outcome, divided by the total number of outcomes. So that's 1 by 6. Now, B, an even number. So as we can see that that's the total listing. So if I'm talking about even numbers, it has to be 2, 4, and 6. So that literally means to respond for the B part. Again, if I'm talking about the even numbers, so there are 3 even numbers out of total, which is 6. So if I reduce it, please do write the answer in the most simplified form. So the probability is half. Number C, a number greater than 3. So if I'm talking about a number greater than 3, so it can be 4, 5, or 6. So that means the probability of a number greater than 3. So there are 3 such numbers, and again the total outcome is 6. So we can reduce it and write the answer in the simplified form. Now, part D, a 3 or a 5. Or means we have to add the probabilities. So please remember, or means addition. So that means the probability of getting 3 or 5. So the probability of getting 3 is 1 by 6. And the probability of getting 5 is also 1 by 6. So that means we literally add these two and we got it as 2 by 6. Again, we'll reduce it to the simplified form. So the answer has to be 1 by 3. So these are the typical types of problems usually asked in IGCSE examinations. Please note this down. Now, apart from this, if we have, if 2 dices are thrown, then the total number of outcomes, if 2 dices are thrown, then the total number of outcomes should be equal to 6 squared. That means 36. Similarly, if 3 dices are thrown, then the total number has to be 6 cubed. which is 216, and it goes on. So if n dices are thrown, so the general formula says that the total number should be equal to 6 to the power of n. Similar thing is with coins. So if n coins are thrown, so the total number of outcomes should be 2 to the power of n, because in case of coins, we have only two outcomes, which is heads and tails. As in case of dice, we have 6 outcomes going from 1 to 6. Now, moving on to the next part of probability, which we say as complement evens. So what does a complement even mean? So complement even is notated sometimes as P of A bar. It's also written as P of A complement, or sometimes also written as P of A dash. So that literally means that the probability of non-occurrence of event A. So suppose if I say that the probability of occurrence of any event A is 3 by 5, so what should be its P complement? So the simple formula says that the probability of A plus probability of A complement should be equal to 1. That's the formula that we'll be using. So since we know that the probability of A is 3 by 5, so plus probability of A complement must be equal to 1. So the probability of A complement is equals to 1 minus 3 by 5. And that's equals to 2 by 5. So that should be the answer for the complementary events. Now, moving ahead from here, we go for a type of problem where we have to use sample space. So now, for the sample space, the type of problems are, suppose if I say that 3 coins are thrown. So what is the probability, part A, of getting 3 heads? B, of getting at least 1 head. Part C says no heads. So if this is the type of question asked, so in this cases, we have to go for sample spacing. As I told you earlier, if 3 coins are tossed, so the total outcome in this case has to be 2 to the power 3, which is equals to 8. So we have to list the sample space in this, that what can be the outcomes. So the outcomes can be head, head, head. That's one outcome. The other one could be head, head, tail. The other one could be head, tail, head. The other one could be tail, head, head. It can be head, tail, tail. It can be tail, head, tail. It can be tail, tail, head, or it can be all tails. So we'll first count that we have got the 8 number of outcomes that we have to get. So yeah, we got it. Now they say find the probability of 3 heads. So out of this sample set, which is the total of 8, we have 1 favorable event to get 3 heads. That means the probability of 3 heads is equal to 1 by 8. Now, if I'm talking about the B part, we say at least 1 head. So that means it can be 1 head, 2 head, or 3 head. So we can say that it has 3 heads, 2 heads, 2 heads, 2 heads, 1 head, 1 head, 1 head. So we have 7 such favorable things. So it should be 7 by 8. No heads means all tails. So that can be 1 by 8. So these are the types of questions asked on sample spacing. Please note this down. It's very, very vital. Now, the other types of questions, which is usually asked in this, is mutually exclusive and independent events. So please remember, if 2 events A and B are independent, so that means if I'm writing probability of A intersection B, so that has to be equal to PA into PB. Or we can also say that P of A union B can be equal to PA plus PB and minus PA into PB if the events are independent. Now, if we are saying that the events are mutually exclusive, then we can say that P of A intersection B is a disjoint set. That means that's equals to 0. Or we can also say that P of A union B must be equal to PA plus PB. So these are the rules for the events to be independent or mutually exclusive. So we'll practice out few sums based on this. So the type of sums asked is this type. One ball is selected at random from a bag containing 5 red balls, 2 yellow balls, and 4 white balls. Find the probability of selecting a red ball or a white ball. So always remember, and it says that the two events are mutually exclusive. So that literally means the probability of red intersection white ball must be equal to 0. So in that case, if you're writing, so if the keyword is OR, as I already told you, OR means to add or means to union. So we have already written that the probability of red union white in that case should be equal to probability of red plus probability of white. So the probability of red ball, the total number of balls is 5 plus 2, 7, 4, 11. So that's the total number. And the probability of getting a red ball is 5 by 11 plus 4 by 11. So that's equals to 9 by 11. That's how we use a mutually exclusive thing to calculate the probability. Please note this down. This is very vital. Now moving ahead to the other type of problem that's usually based on the independent events is like this. So for an independent event, a fair coin is tossed and a fair die is rolled. Find the probability of obtaining a head and a 6. So the key word here is and means multiplication. See, the key word here is and. So and literally means to multiply the two probabilities, or it can also lead to intersection. So the two events are independent. So that means we have already written that the probability of head intersection a 6 has to be probability of head multiplied by probability of 6, which is due to the events are independent. So that literally means the probability of obtaining a head is half, and the probability of obtaining a 6 is 1 by 6. So the probability has to be 1 by 12, and that's the final answer to the question. So this is how we use the independent and intersection events to define a sum in probability. Please note it down. Now, moving on to the next topic, which is a very vital topic in IGCSE, is called tree diagrams. Now, tree diagrams is also known as the generic multiplication theorem. So the key feature of any tree diagram, if it has two branches, so the probability of this is P. So this is bound to be 1 minus P. So the key feature is the sum of the probability of the branches should add up to 1. So that literally means if it has got multiple branches, say like this, and this is X, this is Y, this is Z, this is U, this is V. So the sum of all the things, X plus Y plus Z plus U plus V, should always add up to 1. So that's one of the probability, one of the actions of a tree diagram. Now, the other very important property of a tree diagram is if we are traveling across the branches, suppose that's a junction and we have two branches here. And if we're traveling like this, and that's the junction, and we have at least two branches or multiple branches here. So if this is the probability here is X, this is Y, and I have to reach at point A, and the probability here is Z, and I have to reach at point B. So if I'm starting from point O, and if I'm reaching at point B, so we have to multiply all the probability of the branches given. So that means O in reaching at point B should be X into Z. So from O, if I'm reaching point A, so again, the probabilities of all the branches should be multiplied. So that should be X into Y. So this is how a tree diagram works. So I'll show you an example of about how does a tree diagram question looks like. So yeah, so we can see here, this is a tree diagram question that we'll be discussing. Now it says that a bag contains 5 red balls and 3 green balls. A ball is drawn at random and then replaced back. Another ball is drawn. What is the probability that both balls are green? So for this, we need to draw a tree diagram. So it will obviously have 2 branches. One is red and the other one is green. So there is 5 red balls and the total number of balls is 8. So the probability of getting a red ball has to be 5 by 8. Similarly, green ball has to be 3 by 8. Again, the second event will have 2 branches. So it can either be red since the ball is replaced. So the total set will not change. So this is again equals to 5 by 8 and green equals to 3 by 8. Again, it will have 2 branches. So for red, it will be 5 by 8. And for green, it will be 3 by 8 again. Now, what is the probability that both the balls are green? So that means the first one should be green and second one should also be green. So that means that the probability of both green must be equal to, since I'm traveling across the branches, so as I told, we need to multiply. So the first probability is 3 by 8, and that's also into 3 by 8. So the answer has to be 9/64. So that's the probability that both are green. Now, please note this down. Meanwhile, we'll discuss other problems that's been asked in board examinations. Now, the other type of variation which can be asked to a similar type of sum is they can say 1 green and 1 red. So most of the students make this mistake. They say 1 green and 1 red. So they multiply 3 by 8 into 5 by 8. Now they never said that the first is green and second is red. So that literally means for 1 green and 1 red, if I'm responding, so it can be first green, second red. That's the case of or means to add. It can have first red and the second green. So both of this gives you 1 green and 1 red. So in this case, 1 green and 1 red, that means we are traveling across this arm. So that should be 3 by 8 into 5 by 8, or means to add. So we put a plus sign, then red and green. So in this case, we can see that it should be 30 by 64, or that can be reduced further, write it as 15/32. So that should be the probability, and it's very, very important. Most of the students make mistake over here for 1 green and 1 red. Please note this down. This is very, very vital. Now, moving ahead with the further type of problem asked is we'll be discussing one more type on the tree diagram. So that's the other type of question which is being commonly asked. So it says that a bag contains 5 red balls, 3 blue balls, and 2 yellow balls. So in this case, as we have 3 outcomes, so it will have 3 branches. So that means if I'm talking about this is red, so this should be blue, and this should be yellow. A ball is drawn and not replaced. So look at here. Earlier it was replaced. It says it's not replaced. And then the second ball is drawn, right? Isn't it? So that literally means each one will have 3 branches. It can be red, blue, and yellow. Again, this will have 3 outcomes, red, blue, and yellow. Again, this will have 3 outcomes, so red, blue, and yellow. So we can write red, blue, yellow. This is again red, blue, yellow, red, blue, yellow. Now, the probability of getting a red ball here, so the total number of ball is 10, so that's 5 by 10. Similarly, getting a blue ball here is 3 by 10. Similarly, getting a yellow ball here is 2 by 10. Now, look carefully. Since if one red ball is drawn already and it's not replaced, the total number of red balls now become 4. And the total number of balls becomes 9. So in that case, the probability becomes 4 by 9. Whereas the blue ball's probability remains unaltered because the number is same, but the total diminishes by 1. Similarly, for yellow ball, it becomes 2 by 9. Again, in the second case, since one blue ball is already drawn and it's not replaced, so the blue ball reduces by 2 and rest all remains the same. So that literally means in that case, the probability of red will not alter. So that will be 5 by 9. The blue will alter. So that will become 2 by 9. And the yellow will also become 2 by 9. Similarly, in the third case, since the yellow ball is drawn, so now the yellow ball is 1, and again the total is 9. So the red will not alter. 5 by 9, blue will not alter. 3 by 9, only yellow will alter. So that's 1 by 9. So this is how we create a tree diagram for 3 outcomes. Now it says that the probability of getting 2 red balls. So this is red and red. So if I'm answering the first part, so it has to be 5 by 10 into 4 by 9. So we have to reduce it. So the probability has to be equal to 2 by 9. If I'm talking about the B part, 1 blue and 1 yellow. So that means, again, we can say 1 blue and 1 yellow, or it can be yellow first and then blue. So 1 blue, so that's 3 by 10, and then 1 yellow. So that is equals to 2 by 9. Or means to add. And again, we have first yellow. So it's the probability is 2 by 10 into the blue. So the probability is 3 by 9. So in this case, we got it as 6 by 90 plus 6 by 90. So it's 12 over 90. So we can reduce it by 3. So that's 4. And that's 30. So we can still further reduce it to write it as 2 by 15 as the final answer. Now to respond to the C part of the question, 2 yellow balls. That means yellow and yellow. So that's 2 by 10 into 1 by 9. So the probability is equals to 1 over 45. And similarly, 2 balls of the same color. Now, to respond to D part of the question, 2 balls of the same color can be red and red, or blue and blue, or yellow and yellow. So that's the probability of the 2 balls being same color. So red and red should be 5 by 10 into 4 by 9. Plus, now if we're talking about blue and blue, so that's 3 by 10 into 2 by 9. And if I'm talking about yellow and yellow, so that's 2 by 10 into 1 by 9. So in all these cases, if I solve further, so I got 20 by 90 plus I got it as 6 by 90 plus I got it as 2 by 90. So it should be 28 over 90. So if I reduce it further, so I got 14 over 45. So that's the answer to the D part of the question. Give you a few minutes to note it down and to analyze this. Now, moving ahead to the other very vital part of probability is called Venn diagrams. That's very, very important part and is quite oftenly asked in both paper 2 and paper 4. So if I literally go by the Venn diagram process, so that means if these are two events A and B, and if I cover up the whole area, so that's called A union B. Again, if I have two sets A and B, or two events A and B, so the common area is literally denoted as A intersection B. So we need to know that union is the total and intersection is the common part. So very important form of probability says P A union B must be equal to P of A plus P of B minus P of A intersection B. This is a very, very important form which we normally use in probability equations, and we get a lot of sums based on this. One type of problem that can be asked is they can give you the value of P A union B as something, say, suppose an example 0.9. They can give you the probability of A as 0.2, and they can give you the probability of A intersection B as, say, 0.1. They can ask you the probability of event B. So we have to use this formula. So that means we can write 0.9 must be equal to 0.2 plus of PB, and that's minus of 0.1. So you got it as 1 minus 0.2 as the probability of event B. So the probability of event B is equals to 0.8. So this is one of the proper applications which they quite commonly asked for the union and intersection part. I give you a few minutes to note this down, and then we'll be discussing a few problems based on Venn diagrams. So the problem on Venn diagrams looks like this. In this figure, they have drawn the Venn diagram. In most of the cases, you need to draw the Venn diagram and then discuss. So please read the question carefully. So it says that a group of 30 cats were given two different types of food. 7 cats like only food A, so that's 7 here. 5 cats like only food B, so that's for what they've written 5. And 16 like both and 2 like neither. Since they have said that 16 like both, so both is an intersection or a common part. And 2 like neither, so that lies outside A and B because that cannot be included. Now it says that part. What is the probability that a random selected cat will like both the foods? So that means they're looking for the intersection part. So the probability that will like both the foods, it should be 16, and by the total number of cats, which is 30. Now part B of the question says, what is the probability that a randomly selected cat will only like food A? So if I'm talking about only food A, so that's the one, which is only food A. So it should be 7 over 30. Part C of the question says, what is the probability that the randomly selected cat does not like food B? So that means we have to exclude the entire B part. That means this part has to be excluded. So we are only left out with 7 and this 2, which neither like both things. So that means the probability has to be 9 by 30. Look at the way we responded to the C part of the question. That's very vital. Most of the students make error over here. So the other type of question that's asked on Venn diagram can be like this. So it says that in a class of 25 students, some study French, some study German, some study both, and some study neither. This is the illustrated information on the Venn diagram. So that literally means if I analyze this information, so we can say that 9 studies only French, 6 studies only German, 7 studies both, and 3 studies neither. So what is the probability a student chosen at random from the class studies French? So if I'm talking about French, so that's the French circle, right? So the probability should be equal to 16 over 25. So please remember that it studies French. It doesn't say studies French only. If the word would have been only, we would have gone for 9 by 25. Studies French and German, so that has to be a common intersection, so that's 7 over 25. Studies neither French nor German, so that's 3 over 25. Studies German, but does not study French. So see, study German, but does not study. The intersection also includes French, so that means studies German only, so that has to be 6 over 25. So that's the answer, and that's the way to respond to any Venn diagram questions that's been asked. Please note it down carefully. So yeah, moving ahead from here, we'll be going to the final part of it, which is also known as conditional probability. Now, the conditional probability is a very important part of the probability section. So we write the conditional probability in the form of PA by B. So what does PA by B means? That the probability of occurrence of event A, assuming that B has already occurred. So that literally means I repeat myself, the probability of occurrence of event A, assuming that B has already occurred. So that formula for this is P of A intersection B, and that's divided by P of B. So that means if I'm writing the probability of B by A, so it means the probability of occurrence of event B, assuming that A has already occurred. So again, it can be written as P of A intersection B divided by P of A. So the checkpoint is this probability, which is written in the denominator because the numerator remains the same in both the cases. Please note this down carefully. So yeah, the sums that's usually asked on conditional probability looks like this. On one floor of a bookshop is a cafe. Some people go into the shop just to use cafe, and some just to buy books. Some to do both, and some do not do either. So that's the Venn diagram which they have represented over here. So if I go by the Venn diagram, so that literally means that 25 people go for study books, 12 for both, 8 for only cafe, and 5 go for neither. So this would work out the probability of PB by C. So if I go by the formula, so the probability of PB by C should be equal to probability of PB intersection C. And that has to be divided by the probability of C. So in this case, if I go, so the P intersection C, as we can see, is 12 over here. And the probability of C means I'm talking about this entire circle of C. So that's 12 by 20. So I can reduce it further. So that becomes 6 by 10. Or again, so that can become 3 by 5. So that's the answer to the A part of the question. Similarly, you can see if I want to respond for the B part of the question, so that is the probability of C by B. So that is written as P of B intersection C again, but in this case, it's divided by the probability of P. So that literally means B intersection C, 12 remains the same. Now, in this case, the probability of B, that I now have to take a B circle. So that should be equal to 37. So that's the answer to these type of problems using conditional probability. Give me a few minutes to note and analyze this stuff. Now we're discussing few types of problems that's been asked in board examinations so far. So this is one of the examples. It says that rooms in a hotel are numbered from 1 to 19 and rooms are allocated at random as guests arrive. Part A says, what is the probability that the first guest to arrive is given a room which is a prime number? So that means we have to list the prime number including from 1 to 19. So we have 19 rooms here. So that means what is the probability guest arrives given a prime number? So the prime numbers has to be listed. So that can be 2, 3, 5, 7, 11, 13, 17. So these are the prime numbers. So suppose there are 7 prime numbers. So in this case, the probability has to be 7 over 19. Now, part B of the question said the first guest to arrive is given a room, which is a prime number. What is the probability the second guest to arrive is given a room, which is a prime number also? So that literally means out of these 7 prime numbers, 1 prime number is allocated. So we are only left out with 6 prime numbers, as well as the total number of rooms, which was 19, is now reduced because a guest has already got a room. So in this case, the probability becomes 6 by 18. And if I cancel this out, so the probability becomes 1/3. So that's the answer to this question. I'll give you a minute to note this down. So the other type of board questions that's asked is a bag contains 3 red balls, 4 white balls, and 5 green balls. 3 balls are selected without replacement. Find the probability that the 3 balls chosen are all red. So that means it has to be chosen from the red one. So that means if I have to choose 3 red balls, and it is selected without replacement. So that literally means if I'm selecting the first red ball, so the total number of red balls are 3 plus 4, 7, 5, 12. Has to be 3 by 12, and then again it has to be 2 by 11 because the red ball chosen has to be 1 by 10. So that means I have to reduce it. So that's 3 and that's 4. So the probability has to be 11 by 55 into 4. So that's 220. Similarly, if it says all green, so for the green, it has to be 5 by 12 into 4 by 11 and into 3 by 10. So that means I can cancel this. This is 3, this is 3 on. So I have 5 by 110. And similarly, they're saying 1 of each color. So that means it can be red, white, green, or so we'll have 6 different cases. It can be white, green, red, or it can be red, green, white. It can be green, white, red. It can be green, red, white, or it can be white, red, green. So we have to find the probability of all these 6 cases and add them for 1 for each color. Now, the selection of the 3 balls was carried out 1100 times. How much would you expect to choose 3 red balls? So says this is the probability. So if it's carried 1100 times. So that means 1 by 220 into 1100. So that literally means we are expecting 5 times for the 3 red balls to occur. And similarly, what the probability value we get for the 3 red balls, we have to multiply it with 1100 to get that 3 different color balls will occur. So this is how we go for these types of probability. I'll give you a minute to note this down. So the other type of questions that's been asked is, a bag contains 7 green discs and 3 blue discs. A disc is drawn and not replaced. So the key word here is not. Then a second disc is drawn, copy and complete the tree diagram. So that's 7 by 10, that's 3 by 10, correct? So that means if this is 6 by 9, so this is bound to be 3 by 9. That's because the sum of the branches should be 1. Now this is 3 by 10. So 3 by 10 literally means that the blue disk is already being drawn. So the green discs will remain the same. So this will now become 7 by 9 because it's not replaced. And this will become 2 by 9. So that's how we have to complete the tree diagram that's been asked. So make sure, again, we have to have a cross check that the sum of the branches should always be equal to 1 in the tree diagram. If this is not matching, that means we have made a mistake somewhere and we need to recheck and get the probabilities again. Now, part A of the question says both the discs are green. So that means, see, this is green, this is green. So that means we are traveling across this part of the tree diagram. So the probabilities should be multiplied. So that means in part A, it should be 7 by 10 multiplied by 6 by 9. So that literally means this is 2, this is 3. I cancel this, so that's 5. So the probability is 7 over 15. But this is blue and this is blue. So that means it's 3 by 10 into 2 by 9. So if I cancel this out, so that's 3 and that's 5. So that's equals to 1 over 15. And that's the answer to the question. I'll give you a minute to note this down. Hello students, the other type of questions asked is a table format. A group of 50 people went to a restaurant for a meal. They each chose main course and a dessert. Their choices are shown here. So they have already given you the sum of pizza, which is 26, the sum of chicken curry, which is 24, and the total of this is 50. That's the 50 people. Now, we also have to get for the cheesecake, which is 27, which they have given, for the ice cream, which is 23, which they have given. Usually, we need to calculate these total. What is the probability that a randomly selected member of the group will have chosen part A says chicken curry? So if I go for the chicken curry, so the total people who are choosing a chicken curry is 24. So the probability has to be 24 over 50. We can reduce it further, so that becomes 12 over 25. And that's the answer for the chicken curry. If they say ice cream, so we go for the vertical one. So as we can see that the total for ice cream is 23. So the answer has to be 23 by 50. So please remember, this is a very vital representation, which we usually say as a table format, in which we are adding up the rows and the columns. This total usually we have to make. In this question, they have provided you the total, and the total number of people is always given. So that means the sum of the rows, some of the columns will be 50, and some of the rows will also be equal to 50. Now that's the checkpoint. Once we are adding the rows and the columns, it should always come to the total number of people. So this is how we usually respond to the common part of the question. So please note this stuff. In this, we can also have a variation. If they say, find the number of people who like chicken curry and ice cream. So please remember, if they say something like chicken curry and ice cream, so and is a key word. So and means intersection, as we already discussed above. So that means ice cream and chicken curry. So that's the intersection of chicken curry and ice cream. So the probability has to be 14 over 50. We can reduce it further to write 7 over 25. That can be the final answer. Now, this is very, very vital. So I would expect all of you to note this down. So the other type of question that is commonly asked, so is this: find the probability that of the following are throwing a number less than 8 on a single die. Now, if I have to ask for showing a number less than 8 on a single die, the problem here is less than 8 can be 7. Now, if I'm talking about the probability of 7, so that will never occur. Now, throwing a number less than 8, which is like 1, 2, 3, 4, 5, 6, so that will occur. So that means if I'm talking about the numbers 1, 2, 3, 4, 5, and 6, so in that case, the probability has to be 1. But if I'm talking about the number 7, which is less than 8, so that will never occur. So that's how we have to respond to these questions. Obtaining the same number of heads and tails with 5 coins are tossed. That's not possible because there are 5 outcomes, right? So we cannot have the same number of heads and tails. So that's the probability here will be absolutely equal to 0. Selecting a square number from the set A. So that's 1, 2, 3, 4, 5, 6. So all of them is a square number. So this is a sure shot event where the probability has to be 1. Selecting a prime number from set A. So that means we have to look for the prime numbers that we are looking here. So 4 is not a prime number, neither 9, neither 16, neither 25, nor 36, nor 49. So selecting a prime number should again be 0. So this is how we respond to a couple of questions that's been quite commonly asked in the examinations. So wishing you all the very best for your exam. This is what we had from the probability part. Hope you find it helpful for your preparations. Any queries from the exam point of view or any past paper queries, any questions, feel free to reach out to us at Revise. Thank you all and all the best for your examinations. Thanks.